Alright, I'm back. I'm back. Good at that. Alright, I'm going to open up my phone again because I still don't know how to accurately check how my stream is doing. The tiny little portion I have is I can't see how my screen looks, basically. Okay. My stream is looking pretty good. So I'm gonna go ahead and get started on the problems. So last time we did 37. I think we'll finish today. I'm not gonna do all of these. Some of these are using computer. I'd like to think I'm good enough at coding that I don't really need to do that, but we'll see. We will see. Okay. And I have the solutions up and ready just in case I need them. Hopefully I don't. But anyways, let's get right into this. We have question 38. You lay a rectangular board on the horizontal floor and then tilt the board about one edge. Oh, hold on. One other thing I wanted to do. Could I put chat in now? I was trying to put in chat before. I don't remember how I did it last time. How do I... Settings, maybe? I don't want to break my whole thing. No. Okay. No idea. No idea how I did this. Cool. Okay. Well, anyways, let's let's continue. What is this? What is this? Filters. Oh, that's just cropping. Well, I'm still learning how to stream, clearly. Okay, I don't really know what that does. I'm gonna ignore it. I'm also gonna close my door so you don't see the plate of orange peels that's in the kitchen. Okay. Anyways, back to the problem. You lay a rectangular board on the horizontal floor and then tilt the board about one edge until it slopes at angle theta with the horizontal. Choose your origin at one of the two corners that touch the floor, the x-axis pointing along the bottom edge of the board, the y-axis pointing up the slope. Wait, the x-axis pointing along the bottom edge of the board. Oh, okay. And the z-axis normal to the board. Okay. You now kick a frictionless puck that is resting at O, so that it slides across the board with initial velocity that. Write down Newton's second law using the given coordinates and then find how long the puck takes to return to the floor level and how far it is from the origin when it does so. Okay, let's see if I even understand what the setup is here. So we have a board, a rectangular board, that I'm obviously going to draw a very nice rectangle. Okay. So this is our nice rectangular board. And can I draw? Thanks. Oh, I should show my thing. Hold on. Sorry, still learning. I don't know why this is so big. I'm going to make myself bigger. There. Okay. So we have... I hate how this is just black space. Can I make myself... Oh, no. Alright. So we're just going to have black screen there. Oopsie. Alright, so we have this rectangular board. And we want the origin at one of the two corners that touch the floor. One of the two corners that touch the floor. Oh, okay. So it's a 3D object. Alex, didn't you just say there's a z-axis? I didn't... Shut up. Okay. Let's draw a rectangular board. Alright. So it looks something like this. I cannot draw. You know when those teachers say they can't draw and then they draw Mona Lisa? No. Not me. Okay. So this is our board. This is our floor. This should be theta, I think. Right? Choose your origin at one of the two corners that touch the floor. The x-axis pointing along the bottom edge of the board. Okay. So the x-axis is like this. I hate that. Oh wow, I hate that. Okay. No, that's not quite right. It should be something like, well, okay. So if this is the board, I'm gonna spend the whole time just drawing. Something like that, right? So the x-axis should be something like this. Okay, this is gonna ruin the whole drawing, but this is our x-axis. What is y again? Y pointing up the slope. Okay. So y is like this. And then z is normal to the slope, right? Okay, that works. Z-axis normal to the board. Okay, something seemed wrong about this drawing. Well, I'm gonna undo this. I feel like the y-axis should... Okay, the x-axis is along the bottom edge of the board. So the y-axis should go along the board as well, like this. Right? And then our z should go like this. Yes. Okay. That, I think, makes sense. Am I at least understanding the problem right? Okay. Oh great, another frictionless puck. I hate frictionless pucks. It's resting at... Okay, this is where you already lose me. How can the puck be resting on the bot? The origin is inside the board. I must not be understanding this right. It's resting at the origin so that it slides across the board. Okay, well, maybe this is... Okay, forget the picture. It's, say the puck is here. We kick a frictionless puck that is resting at O so that it slides across the board with initial velocity that. Write down Newton's second law using the given coordinates and find out how long the puck takes to return to the floor. Okay. So we're going to try to use forces again. Oh, it kicks across the board. Oh, wow. Okay, that's freaking confusing. So, no, it goes up like this. So the puck... Okay, this drawing is terrible, but the puck's going to go diagonal. And obviously it's not going to jump off the board, so z should not change. Okay. But z should be... Well, there's no acceleration, so the force should be 0. But there is a normal force acting on it. And there should be... like some... So we have... Oh, wow. Okay. Okay. Let me think about this. Okay, so... mg is this way. Wow, I'm really struggling here. So it kicks... Okay. It kicks the puck diagonally across the board. If I'm understanding how the board works, which I'm not 100% sure I do, it kicks it across the board. Wait, I'm just realizing. Is this... Let me turn this down. I don't know if that's giving extra echo. Wow, we're going to get one problem done again. Okay, these are tougher, but I'd like to try some of them. Okay, no, we'll skip the harder ones, and we'll just do the easy ones. One at a time. We can't even do the easy ones. Okay, we kick it diagonally. How did we do it last time? Yes. Okay. Wait. See, that's how I did it last time. But there's a z-axis now, which kind of throws the whole thing off. Okay. So x and y should both change. No, x should have... It's frictionless, so x should not change. Y, however, should. But wouldn't that also change x? I'm getting confused. X has no acceleration. So x should... If you're thinking about a hockey puck, it should slide like that, at the same speed. It shouldn't slow down going in the x direction. The y direction there should be. The question is, what would that be? I feel like... Okay, so mg... I'm going to just forget the axes. mg would be like this. That's mg. It goes down. So there's a downward force as such. This would be... Would that be theta or pi over 2 minus theta? That's... See, this is always the hardest part with these. That would be... Okay, this would be... Hold on, I'm thinking. The gravity would go down like this. Gravity, that's mg. And the negative force is going like that. So what is this angle? I think it's just theta, right? I think it's just theta. So that'd be cosine theta. Would it not? Am I stupid? No, it would be minus theta. So it'd be 90 minus theta. So this would be, I think this angle is pi over 2 minus theta. So that means that it's really mg sine of theta, I think. But this had a force, which is why I'm so confused. Well, that had a force because... It's frictionless. Y is now up, so Y has the force. Okay, I think this makes sense. I'm forgetting about normal force. I don't care. I'm not doing that part. Who needs it? We don't need it. Okay. So, I think our acceleration in the y direction. So, ay of t, or... Yeah, I'll just leave it like that. That should be negative mg sine theta, I think. I'm going to check my answers. I have the answer key again. But I think that's right. Okay. Differentiate this. Differentiate? I'm actually going for a PhD in applied mathematics. Integrate is what I meant. I meant integrate. God. Okay. So this would be negative... Oh, I'm an idiot. Not mg. It's just g. Sorry. Because the force is mg, but that's mass times acceleration, and then the g is sine theta. Yeah, you got it. So it's negative gt sine theta plus some constant, and then we have our position, which for some reason we call r in this physics realm, which I hate, but whatever. I'm sensing a very common theme of this negative gt squared over 2 sine theta plus c0t plus c1. I feel like I don't understand this enough, so the next chapter is not going to make a lot of sense, to be 100% honest with you, but we'll learn as we go. I mean, the general principle makes sense, I think, but let's just continue. I'm a little bit nervous because we have an initial velocity. Well, no, we should have a position. So we get a position from that. That's what we want, and how far it goes. Yeah, okay. So it has initial velocity of v0y. So at vy, so initial conditions. So this is connected, right? Initial conditions. this gives us v0y of 0 is equal to negative g 0 sine theta plus c0 is equal to v0y. So obviously this means c0 is equal to v0y. And then our final position should be 0 because, whoops, we don't actually know what our final time is, do we? That's a wanted, that's what we want. But we know what c0 is. We know that our final time is equal to 0. How long it takes. I'm missing something. What am I missing? I think I'm just having a brain fart right now. Oh, the position is 0. Position is 0 at time 0. Oh my lord. Who would have known? Okay, so negative g0 over 2 sine theta squared, technically, plus v0y times 0 plus c1 is equal to 0. So that means that c1 is equal to 0. So our position in the y direction is negative gt squared over 2 sine theta plus v0yt. And then I don't have to do the rest of this to know that in the x direction, it's just the integral of, or the antiderivative of v0x, which should just be v0xt. Whoops, it should be vxt plus, wait, what's happening? No, it's v0. My god. The velocity is constant. So it's always v0x. Integrate it. v0x of t. Yes. No, not of t. Times t. Okay. Oh my lord. Alright, now what do we need to do? We need to find when this is equal to 0. We need to find when this is equal to 0. So let's go to the next page. See, this part is, once I have what the acceleration is, that's, everything else is pretty easy. Everything else is just differential, very, very basic differential equations. It's the figuring out what the hell is going on with the physics part. Alex, isn't that because this is physics? This is why it's not good to just major in math. I also minored in CS, I'll have you know that, okay? Very tangible, real things in CS. Alright, let's get back to work. So we need to find when the position of y is 0, because that's when our whole trail thing will end. So we have r0, and we know that it's 0 at t equals 0. And I think we did this last time, if I remember correctly. So we want r0y of t, no. Want when this is equal to 0. So this is equal to negative gt squared. I'm just going to copy this. How long it takes to copy, it might just be faster to write it, but and we're going to set it equal to 0. Yeah, look at this better. Set equal to 0. And so if we pull out a t, we get v0y minus gt over 2 sine theta is equal to 0. And we already know that, well, we already know, is this going to be the same exact answer? Hold on. If I remember correctly, this is what the answer was for last time. Except that time we were doing x in the upwards direction for whatever reason. So we already know that t equal to 0 is a solution. But can't find it on the other. So this would be, so we have just solving for this in my head. That should be 2 v0y over, hold on, let me move this over. It should be t should equal to 2 v0y g sine theta. Did I do that right? I think so. Yeah. Okay. And then we also need to find how far it went after this much time. But this is exactly how long it took for the last time. So this is how long it takes for the puck to reach the ground. But if there's no friction, it should take the same amount of time no matter which direction you kick it. If you kick it straight up, if you kick it to the side, it should get to the ground at the same time. But obviously your x distance will change, or in the case of the way we did it last time, your y direction will change. Because I'm so smart. Okay, so now we just need to plug this in for our position of our x direction. So this is v0x. I mean, this is literally just putting next to it. So it's 2 v0x v0y for g sine theta meters. Forgot there's oh wait, no, they didn't give us units, did they? Suckers. Okay, these are my two final answers. I don't know. I really don't know what he means by the whole force thing. I feel like he just means to write the three forces. I think this is right, though, in terms of the positioning. We're going to find out. I hope I'm right. Let's see. Oh, wow. Their picture's a lot different than mine. Their picture's a lot different than mine. Why is their board like a trapezoid? Not trapezoid? Oh my god, I meant parallelogram. Well, somehow I got the time right. I think I understood the problem right, I just didn't know how to draw it. And I got it right. I got it right! Woo! I actually got that right? I do understand this? No, I don't. Yeah, the y component is... I'm trying to... I want to see their explanation because I do not get it. Yeah, they have downward force like this. The x-axis pointing along the bottom edge. Their picture makes no sense, I'm not gonna lie. The y component is mg cosine 9 minus theta minus mg sine theta. Okay, I think they made a typo in this explanation. Okay, it's just the thing. Okay, I think that makes sense. Okay. I think it makes sense, but I really don't know. Alright, I think I see what they're saying, maybe, I don't know. Their picture's really bad, I think. Not that my picture is great, but I think their picture is not great either. Okay, let's pull up the textbook again. Let me fix myself. Okay, I'm gonna be here now. Why not? And let me load up my next page of my notebook here. I'm not gonna do 39, I don't think. Let me read it just quickly. No. Nope. Not doing that one. This is going to take too long. I want to move on. I feel like I get the idea here. Polar coordinates. Okay. I know how polar coordinates work, but not in the physical setting, so I think it's good practice. Anyway. Section 1.7. Two-dimensional polar coordinates. Okay. I think this will really test if I know what I'm talking about. Guess what? I'm not gonna know. An astronaut in gravity-free space, yes, space, that's what I meant to say, is twirling a mass m on the end of a string of length r in a circle with constant angular velocity omega. That's right. I almost said w. Write down Newton's second law in polar coordinates and find the tension in the string. Write down Newton's second law. Okay, they give me the formula. Okay. Well, let me just write the thing. So we're twirling. Let me switch the screens again. I can make myself big again. Perfect. Okay. So we're twirling a mass on a string in gravity-free space. I cannot speak. In spray. The new word is sprace. I've just decided. So we have a mass m. A mass m, that's going to be a circle. You know what? Just to be contrarian, I'm going to make it a freaking square. You know what? I'm going to make it a trapezoid. I almost said parallelogram. I don't know my shapes, apparently. There's our shape. Where are we rotating it? Which way are we rotating it? We don't know. It's usually counterclockwise. So we're rotating our thing counterclockwise. Does it look better like this? How do you draw the motion? Like that. I don't really know if that's how you draw it. Whatever. We're twirling our trapezoid M on a string of length R in a circle with angular velocity. So it twirls. Whoops. Twirls at an angular velocity of omega. Write down Newton's second law in polar coordinates and find the tension in the string. What is 1.48? This is a long textbook, my lord. Okay, oh, they have in polar coordinates. 2D polar coordinates. Yeah. So you have the force. Okay, the force with respect to the radius and the force with respect to the angle. Okay. Well, how the hell do you figure this out? Alright, we know angular velocity. Okay, we have. What do we have? Constant angular velocity? Let me just write down what the 2D polar coordinates are. So we have F is equal to mass times acceleration, which is equal to our piecewise function, f of r, which is equal to m times acceleration of the radius minus this squared. F m r. Okay, well this isn't really. This is a little confusing because r is position, so I'm gonna just get rid of that. Okay. 2r dot. Whoops. 2r dot. Was angle dot. Okay. This should be a parentheses at the end of both those. Well, the radius should not change. The radius should be constant. So I believe that FR, so the radius should be constant. So R dot and R double dot, just do this in the comma notation, equals 0. And R is equal to big R. So we should have that FR is equal to the mass times negative, which should be negative R, no, negative M R times phi dot squared. The question is, how does phi change? I forget how that works. We have our angular velocity here. Something with omega, obviously. So we have, for rotating something on a string, how does this work? How does it work in polar coordinates? Oh, I'm an idiot. I'm an idiot. That's the angular velocity. Oh, wowie. Okay. And it's constant angular velocity. Additionally, that is equal to, by definition. So we have okay, so we have F is equal to FR is equal to negative MR omega squared, and then F phi is equal to M. No. Isn't it just 0? Am I crazy? Because this is 0 and this is 0. So it's 0. I'm pretty confident in this, but I am not 100% sure. If there's no angular, if there's no acceleration, then there's no. That makes. No, wait. This isn't making sense again. Oh no. Oh no. No, it does make sense. I think it does make sense. Let me just make sure I wrote down the law right. I did. Yes. Okay. I think this is right, maybe? I feel like such an idiot. Constant angular velocity. And find the tension in the string. Should the tension not just be the force of the string? Okay, well, that's definitely the force. How do you find the tension in the string? Is that not just what the force is? I'm clearly not understanding. I'm clearly a physics idiot. Particular. No, those are the two components of force. There should not be another component. That's by definition what our force is. What am I missing here? I'm reading the textbook right now. Reading the textbook, seeing what I got wrong. We have constant angular. We have constant angular velocity. I do not see what's wrong with this. What would the tension be? All right, I'm looking at the answer key because I don't know what the tension would be. If it's not the force. Also, they didn't give us any units. How dare they? Okay, that's not 41. Where's question 41? Oh, here we go. I'm really nervous to look at this. I feel like I did something so incredibly wrong. Oh. Okay. I was almost there. So the tension in the string, it's positive mr omega squared. But everything else I did right. So the negative force is acting towards the center, so the string has to counteract that, which would make it exactly 0. Okay. All right. How many more questions do we have? I'm gonna go up to question 44, and then I'm gonna move on. I think. So I think it gets to a point where I'm kind of beating a dead horse here, and I want to move. I don't want to just keep doing high school problems, because unfortunately these are high school problems that I'm struggling with. Okay, all right, but this is what I'm telling you. And if you guys ever feel like you can't understand something, just appreciate the fact that I don't know what's going on, and I am doing a PhD program. Okay. Prove that the transformations from rectangular to polar coordinates and vice versa are given by the four equations 1.37. Explain why the equation for phi is not quite complete and give a complete version. I'm just realizing this is cut off, isn't it? You can't even see this. Wow. How incredibly professional of me. This whole time you guys are not reading the whole question. Alright, lock that in so it doesn't move. Okay. Prove that the transformations from rectangular to polar coordinates and vice versa are given by the four equations. Prove that the 1.37? What's 1.37? Let's find it. We're almost there. Prove that what? Oh, prove this? I better be able to freaking do this. Okay. So I want to prove that what? That this is... Okay, I thought this is really easy. I threw it back and forth, so I need to prove both ways. So we'll do forward way first. What question is this? 42? And before I forget, I'm going to plop this on the screen so you guys can see. You fail at this? Hopefully not. I hope I can do this one. What happened to this? Oh no, it's good. Okay. I thought it was wrong. I thought it was something was messed up. Okay. Alright, so we're going to prove the forward way first. So if x equals to r cosine of v, also why are they using phi? But whatever. So obviously we have well, I mean, we could just square them though. You have x squared plus y squared is equal to r cosine phi squared plus r sine phi squared. It's equal to r squared times cosine phi squared plus sine phi squared. And then this is equal to 1, obviously. So then you have r is equal to the square root of x squared plus y squared, because the negative version is not a solution. Okay, well that part was easy. Now we need to prove for phi. So we have we should try to do something like y over x is equal to r r sine phi over r cosine phi, which is just equal to sine phi over cosine phi, which is equal to tan phi, which means that if we want to solve for phi, we just take the arctangent of y over x. Okay, so that's the forward way proved. And I proved the backwards way. So assuming we have r is equal to x squared plus y squared, we can get, so we square it. I mean, isn't this just doing this backwards? R squared is equal to x squared plus y squared. Okay. And then, I mean, we could just... I mean, this is just checking that it works. So if... that's just plugging and chugging. You just say, oh, well, if x is equal to r cosine phi... No, I don't think we need to prove both ways. I think it shows that from this way. I don't know why I thought we had to prove that both ways. I'm just an idiot. Because we could just reverse everything we just did. And it'll get you the same thing. So that's proved. We don't need to worry about that. Okay. Let's go back down. That was surprisingly easy. Because that was the math one. But I don't think that's why I was, wait, what is this? What did I just do? I just made it so much nicer on my screen. How the heck did I do that? I can actually see what's going on now. How the heck did I do that? Oh, I just clicked something. I have no idea what I just did. Alright. I mean, I'm cool with it. Makes it a lot easier for me. Okay. Let me pull up the book again. And let me shrink myself. Move myself here. Okay. So now we want to go to question 43. We'll do 2 more questions. Prove that this is just more math. I'm going to learn physics, not math. Prove that the unit vector r of 2-dimensional polar coordinates is equal to that. And find a corresponding expression for phi. That the unit vector of 2-dimensional polar coordinates is equal to that. Okay, so in unit vector you have 2 things. Isn't this just a lot of the same exact thing we just did? You have 1 unit in one direction. So the unit vector in polar coordinates, this is just 1, 0. Oh, I'm not sharing the screen. Make myself big. And that is equal to, so you have, if you want to transfer that to polar coordinates, that would be, whatchamacallit? Oh boy, am I stupid? I forgot to put a squared there, just realized. Well, that's the norm. R would be the norm of the magnitude over directions in both. So why am I brain farting how to express this in a matrix? I mean, obviously, intuitively it makes sense, but I cannot figure out how to express this as a matrix, and I don't know why. Maybe I should just not express this as a matrix, but okay. R should be equal to, like, you should have x, like the transformation should be why am I struggling right now? if it's a unit vector, then our direction r is 1. So if we have this is equal to 1, so we know that 1 is equal to x squared plus y squared. And we know, oh, technically, but then, yes, it's also this. X squared plus y squared is equal to 1. But that's only true if x, or I guess, it doesn't matter, but it should be x's cosine and y's sine. So this is only true if that's cosine no, that I feel like I have to be on the right track here. Cosine phi what the heck am I? No, the magnitude x has to be cosine. So x equals cosine phi. Because this is just magnitude. So the magnitude x is cosine phi, the magnitude y is sine phi. So therefore our vector should just be x times cosine phi plus y sine phi. How is that wrong? Okay, I'm pretty confident that's right, because x and y are just the magnitudes of our x and y vector. So we know that the magnitude of r of our unit vectors, we know the unit vector's magnitude is 1. So and that same magnitude is given by the square root of x squared plus y squared. So I can find the corresponding units accordingly. That's right. I don't care what Taylor has to say. I'm sorry, Taylor. I don't even know. I'm not even gonna comment. I was gonna say something, but I don't know. Let's continue. Oh my god, and it's just me in the chat right now. But if there's anyone watching this in the future, you don't know how much nicer it is knowing that I can read my screen on my computer now. I don't have to look down at my phone. In fact, I'm going to turn this off. No, now there's no viewers, but... there's no more viewers, but it was just me, the one concurrent viewer. Alright, let's just continue. Okay. Alright, we're going to do the same thing for phi. So for phi, we know that our magnitude has to be this. So we know that for phi, our magnitude of our vector... Can I draw the norm sign, please? That's 1. So that means that 1 is equal to arctan y over x. Yes. But what value gives us 1 for arctan? You would have to have pi over 4. Right? That's when they're both equal? Would you believe I'm a mathematician? I'm pretty confident it's pi over 4. Oh, that's actually pi times 4. I don't do trig stuff anymore, guys. I haven't done it since PE's a whole year ago. Yes, it's pi over 4. So this means that y... Well, what does this mean, actually? No, it's what value. I mean, we can just solve this legit. So we can just take the tangent of both sides. So tangent of 1 is equal to y over x. Tangent of 1. What is tangent of 1? That doesn't make sense. If it's a unit vector, are the units for that different? I don't think so. I'm just realizing tangent of 1 makes no sense. I mean, it's kind of makes sense, but not really. Would a unit vector be defined as, like, pi or something? I don't think so. By definition, a unit vector is length 1. But do the angles have different units? I just don't know. I think by definition the answer is no. I need to look. I need to look and see if they mention it, because that's kind of important. What's the length? Yeah, they're perpendicular. Yes. Notice that we can define the unit vector. The unit vector that points in direction increasing one is fixed. Got an email. Alright, so this is just explaining vectors. Yes. Yeah, there is a small subtlety concerning the equation for phi. You need to make sure phi lands in the proper quadrant. Yeah, but I'm still confused. I must be so stupid, because I'm blanking right now. You take the tangent of phi, which is 1. What? I don't know what's... Unless it is just tangent 1. I don't think that's the case. I don't think that's right. I'm gonna have to look it up, because this is really sad. How am I this stupid? Am I actually this stupid? That's crazy. Alright, I'm looking it up. I don't care. I'm confused why the unit vector... That by definition should be true. What I have written down should 100% be true. If phi is a true unit vector. The one thing I'm iffy about is the fact that the unit vector may or may not be 1 in polar coordinates. That's the one thing I don't know. Which it must not be, because otherwise this would be the answer. Unless I'm really just stupid. Yes. I don't even see the answer to this question. Yes. Yes. Oh, wait. I'm on the wrong problem. I was wondering. Oh, I just realized I didn't do this part of the last one. Whatever. We're skipping it. I already just saw the answer, so I forgot about that last part. Okay, this is a different way of doing the same thing, but yes, I got the first part right. Okay, they did this a very different way. So they did it. Yeah, the magnitude is equal to 1. That's what I thought. What just happened? Alright, there's gotta be a better way to do this. What I have should work. I'm trying to understand why what I have doesn't work. If I plug in for y and x, no, doesn't work. I don't know why what I have doesn't work, to be quite honest with you. Okay, let me do it their way. As clearly they know what they're doing and I do not. So it's equal to 1, which is equal to the square root of phi x times this plus phi y times y. Why is it negative x? Okay, apparently it's negative x. Because this is the picture they have. Draw very quickly. Which obviously, yeah, makes sense. So this is r. This all makes sense, what I'm about to draw. I understand this all completely. What I don't understand is why my proof does not work. And I don't know if I don't know if I will ever know. Phi. So this is x equals r cosine phi, and this is, yeah, I wrote that. Alright, that's everything. So they're saying that phi is negative. Okay. I mean, that's if phi is going that way. But sure. I mean, it depends what quadrant it's in. Seeing a different answer for each quadrant. Okay. That's probably why my thing doesn't work. Okay. Alright, that makes sense at least. I still feel like there's another way to do it without using the geometry, the trigonometry, but whatever. Okay, let me just try to solve from here. So, oh, excuse me. So now we need components for the x direction and the y direction. What would the x direction be? What's the magnitude of this? Well, if you go like this, that would be adjacent. Wouldn't that be? I remember the answer says sine, so that's clearly not the answer. Why is that? Okay, we want this. Oh yeah, no, I'm not getting it still. That would be the y direction. We want. I'm trying to see. There's no viewers. I don't know why I can't put chat on the screen, but. You know what? I'm gonna give myself a little mental break. I'm gonna figure out how to put chat on screen. I don't know why I can't put stream on the screen. Text, maybe? Chat log mode. Change the color. Give it red. I don't really know how this is gonna work. Where's the text? Okay, get rid of it. I don't know where it is. Go to set on client. Display capture. Oh great. Just displayed my whole screen. I hope that didn't show my email. I'm gonna check the stream now. Okay, it didn't. It showed. Wait, what did it show? I don't want to dox anyone. It showed I was on Reddit. It showed I was looking at C++. Alright, I mean, it showed my stream, but that's fine. Alright, I mean, what are you gonna do? I don't know how to add chat. How to add chat in OBS. What? Browser? Oh, I need to go to my stream. Okay, that's annoying. I don't know what I'm doing. Na, 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 na. How do I do this? Na, na, na. I don't know. Oh, oh, oh. 3 dots. Oh, okay. Pop out chat. Can I just copy the link to this? Why can't I copy the link? Alright, fine then. No, not fine. I don't know what... How do I do this?